Hi, good afternoon and welcome. My name is Leslie Wolf. I'm InterDrone's conference producer, and I want to thank you all so much for joining us today for this webinar. Today's topic is BVLOS and its real-world energy applications, presented by our speaker, Jason Hardy-Smith of IRIS Automation. Before we dive in, I've just got a couple of quick housekeeping notes. So this audio portion is being broadcast over the internet. You're going to want to make sure, of course, that your audio is unmuted, that your volume is turned up. If you're having any sort of audio issues, there's a little question mark that you can hit to do troubleshooting, and that should be able to solve the problem. We have also found that just logging out of the webinar and logging back in should fix any other sort of technical issue. And then question asking. So you can feel free to ask questions throughout the presentation simply by going to the bottom left corner of your screen and typing into the Ask a Question box. Questions will be answered at the end during the Q&A portion, but if you have any sort of technical questions to ask, you can feel free to type those in, and we have staff ready to answer and help you out. All right, so our speaker, Jason, is the Vice President of Product for IRIS Automation. And so with that, I'll hand it over to him to get us started.
Thanks so much, Leslie. I'm really excited to talk to everybody today. And thanks for setting up this webinar, InterDrone. Today I'm going to be talking about BVLOS, flying beyond visual line of sight. So, why do we want to do it? What industries does it really make sense to do it in? What technologies are there to support us? And then obviously we have to navigate all of the regulations out there. Right now we, have to get waivers, which is not the easiest thing in the world. How do we get from, trying to get waiver permissions to actually, scaling this to just complying with standards and be able to fly BVLOS, without going through, without jumping through all of these hoops. A little bit about me. My name, as Leslie said, I'm Jason Hardy-Smith. I've been in the technology industry for, over 20 years. I started off in electronics and, really started my career as a software engineer for Oracle. And was with Oracle for a bunch of years and kind of transitioned into product management. And then I worked in a bunch of startups where I really enjoyed coming up with new products that that were new to the market, that really transformed or disrupted industries and really made an impact on the world. That's what really excited me, and is part of the reason I got into the drone space. I mean, obviously, I think primarily drones are cool, right? Everybody wants to work with drones, but beyond that, it's just a tremendous opportunity, right? The applications for drones are so numerous. I feel like every week, once, maybe twice, I'll talk to a customer and they come up with, an idea, an application for drones that I just never thought of, and it just kind of blows me away that that's still happening. Like I think, what day is it, Thursday? I think on Tuesday I talked to a police force who has percussive sensors throughout a city, and they, with these percussive sensors, when a gun is fired, they can triangulate the position of where it was shot from, and they want to instantly send a drone there. And I hear things like this every day, and it keeps me really excited about the industry, but it also makes me think of the applications of BVLOS and how that is really going to increase exponentially the number of applications out there and the impact that we can really have with drones across industries as a whole. So with that said, what I'm going to talk about today is, like why we should be flying BVLOS with drones. What are some of the industries where we can show great success? And I'm going to focus on the energy industry because, well, a couple of reasons. I think it's a great industry for demonstrating the return on investment of flying BVLOS, but also we've really seen, in these times with COVID, how the energy industry is impacted. people in the energy industry are coming to us every day, because they're really having trouble in COVID with social distancing and everything else, and trying to maintain the daily inspections and maintenance they have to do, especially in long line infrastructure. And so I want to focus in on that industry as particular as an example. And, you know, having made the case that BVLOS makes a lot of sense, how do we really get there? You know, what are the requirements? And I'll talk about the, you know, iris automation. We talk about the 4 pillars of BVLOS. What's the 4, you know, requirements that you have to attain to be able to fly BVLOS? And that's really, you know, sufficient C2 links. It's mitigating ground risk. It's having, you know, reliable, safe operations, and it's mitigating air risk. And it's really that air risk mitigation part that at iris automation we focus in on. And then, you know, having all the technology in place and all of your operations in line, you still have to be able to comply with regulations, right? You still have to get waivers. So, and that's a difficult process today. You know, getting a waiver, you know, means a 600 to 700 page document that you've got to put together. There's a lot of information and, you know, details that have to go into putting that together. It's a multi-month process. But, you know, there is a pathway through it. So I'll talk a bit about that. And then, you know, how do we really scale? You know, it's obviously approvals here and there is not really scalable. We want to get to hundreds of thousands of approvals for flying BVLOS. So I want to talk about some of the ways that as an industry, we are going to get there. Before we really get into the presentation, we're actually going to kick off a poll and ask about, you know, why each of you are really interested in BVLOS capabilities. So we'll take a few seconds to allow you to respond to that. Okay, let's continue on then. Thank you for your responses. I want to talk a little bit about the industries where BVLOS is really suited to. Search and rescue is a really good one. If you think of, like, you know, avalanche, landslide, flood, earthquake, you know, these are dangerous environments to send people into. Flying a lot of helicopters or planes around there also has dangers associated with it. Getting drones in the air to be able to search for people is, you know, a really great approach to this. But we don't want to compound the disaster area by, you know, crashing a drone into a helicopter or something like that, right? We got to make sure we do it safely. But, you know, really a great use case for flying BVLOS. Air taxis is another great one, right? You know, there's a lot of promise there. We're very, very early stages of air taxis. Unless we can fly air taxis more than 3/4 of a mile, there really is no use for it. So we want to drive to beyond visual line of sight there too. Everybody these days wants an Amazon package, you know, within 30 minutes of clicking on that on that buy button, you know, and so, but beyond that, like, there's a lot of really important uses for package delivery. Like, you know, somebody's having a heart attack and you want to get a defibrillator out there as soon as possible. You know, you want to get blood somewhere or some drugs somewhere in a remote place really quickly. Having helicopters or planes on standby for this is extremely, extremely expensive. Precision agriculture is also another good one, you know, to, you know, be able to inspect your crops at low cost, miles and miles of crops, making sure that, you know, that they're getting sufficient amount of water, that, you know exactly when to harvest them. It's a great use case for BVLOS. But, you know, the long line infrastructure inspections is probably even more applicable. So we think about railway lines. There's 140,000 miles of just freight railway lines in the US. Pipelines, you think of pipelines in Alaska where it's snowing, trying to get helicopters in there, maintaining the flight crew, having fuel there. It's a huge operation. Or, oil pipelines through the Sahara Desert, too hot, it's not great for your crews. And then utility and power lines. In the United States alone, we have around about 160,000 miles of high voltage power lines. Like, for me, that's a really hard number to imagine, how far 160,000 miles are. And so I figured out how many times around the world that is. It's 6 or 7 times around the world. So trying to inspect that distance of cable every year using, daisy chain and visual observers or using ground control systems, very, very difficult, really, really expensive. Here in California, Iris Automation is based in California, San Francisco, and north of us, we've been having a lot of trouble past few years with wildfires, as is many areas around the world. But part of the reason for that is that the power lines went up 40 years ago. Trees have grown around about them. The wind blows, the trees touch the power lines, fires get started. And so obviously we want to inspect them regularly, make sure that they're clear and there's no danger, they're maintained properly. But it's a huge effort. You can't drive up to them because there's trees around them, they're over mountains, it's a dangerous environment. Helicopters are really expensive, planes are really expensive. We need a lot of people to do it. And so it just becomes a really expensive proposition, and you end up with like PG&E going bankrupt, etc. So beyond visual line of sight operations really make sense for these type of environments. So we can avoid using helicopters and planes and save a lot of money, can use far few ground crews. I think if we're trying to do this with visual observers, we're, all getting out of the car, setting up, performing the flight, doing a tear down, back in the car, moving a few miles down the road. It's incredibly inefficient. With one BVLOS flight, we can collect a ridiculous amount of data, and it's infinitely more efficient, and we can reduce the number of personnel. It's kind of a no-brainer, right? We have done a bit of a cost comparison here. Now, there's a lot of assumptions in this. You can actually go to our website, irisonboard.com, and there's an area for use cases. I encourage you to go there. We have a PDF that you can download, and it will talk you through the various assumptions that we made. And you can actually plug in your own numbers and do a bit of an ROI calculation for yourself. But, from this one, you can see line of sight operations cost about $500 a mile. BVLOS about, 9th or a 10th of that, $65 a mile. That's a huge saving. 100 miles per crew with current LOS, 1,000 miles per month per crew for BVLOS. Now, obviously, there's a lot of detail in that, but let's go back to that high voltage power line example of the 160,000 miles in the US, the 6 or 7 times around the world. That is going to take you about 130 crews with the line of sight methodology, and it's going to cost you about $80 million a year, right? Versus about $10.4 million a year for BVLOS and taking only 13 crews. That is a ridiculous saving, right? And, if we think of the scale of the benefits of flying BVLOS and extend it across industries, we are talking about railway lines, pipelines, gas lines, any other large infrastructure inspections, refineries, package delivery, et cetera, all, we can kind of extrapolate this out to huge return on investment across industries, across companies around the world. So, assuming based on, some of the benefits I've talked about, like the safety of your personnel, the return on investment, the efficiency, the amount of data that you can collect, how do we actually get to fly BVLOS? And You know, as I mentioned at Iris Automation, we talk about the 4 pillars of BVLOS, 4 requirements, and their reliability, command and control, ground risk mitigation, and air risk mitigation. Taking the first one first, this is really around your operations. Like, do you have a reliable platform? You know, a reliable drone that actually meets the needs of your mission? Are you, you know, maintaining it properly? Do you understand that your battery only has, you know, 50 flights in it, and you know that you're at, you know, flight 45 and it needs to be renewed soon? Are your, you know, pilots trained properly? Are you logging all of your flights? All of these things you're going to have to document. Command and control, ensuring that you know the power requirements of your C2 link. You know you're in active control with your drone at all times. You understand any of the obstructions in your flight, where there might be dead points, and you know you need to do real world testing on your command and control links too. For ground risk, you know, if you're going to fly over people, there's obviously a chance that your drone could fall out of the sky, and you know, drones can be extremely heavy. They're going to do damage. They could, you know, people could get injured. Could be fatalities. Could be damage to property. You have to show how you mitigate these risks, and you can do that in a number of ways. You could just not fly over people. You could fly out in rural areas where there's nobody there, but you still have to think about things like, you know, are you going to fly over a road? Are you going to fly over a river where there might be kayakers? Are you going to fly over somebody else's property? And how do you avoid that risk? Do you fly around it instead, or do you just always fly on your own property, maybe when you're inspecting your pipeline or whatever your mission is? And then the last one, which is dear to our heart here at Iris Automation, is air risk mitigation. So really what we have to do when we're flying BVLOS is, you know, stay well clear of any other, you know, manned aircraft, cooperative and non-cooperative. So, you know, things are a little better than they used to be. Now we have about 30 to 40% of the manned traffic having ADS-B out, or some other transponder, you know, so it would be a cooperative aircraft. But that still leaves 60 to 70% that don't. And so, you know, we got to think of ways in which we can mitigate that air risk if we want to fly BVLOS. I really like this quote from a guy called Mark Bathrick, and he's the director of the Office of Aviation Services at the Department of Interior, and he manages one of the largest drone fleets in the world. And I'll read his quote out. It says, "Number 1 on my wish list is what I call the holy grail of drone technology, and that would be a self-contained, non-cooperative, fully autonomous sense and avoid system. I don't want to go and talk to the drone. I want the drone to fly where I've programmed it to fly, do what I want it to do. At the same time, I want it to see everything and miss everything." So, you know, just breaking that down, the holy grail for him is, you know, basically having something on a drone that allows the drone to see like a pilot does, kind of understand its surroundings and, you know, stay well clear of, you know, any manned aircraft out there, and otherwise just do its job by itself, right? So it's a pretty difficult proposition, right? This is an image from one of our drones that's out doing long line infrastructure inspection. And you can, if you look at the bottom left-hand corner, there's a little speck there. You can see our system has identified something. And it turns out, you know, what that is actually a paraglider. And there's a ton of things like paragliders out there, right? There's, you know, hang gliders, microlights, parachutists, power parachutes, you know, Cessnas, crop dusters. And a lot of these things, you know, they're small. Some of them don't make any noise. They're flying pretty low. They don't have radios, you know, they're unannounced. They don't have ADS-B out. And so what we really have to be able to do is, like Mark Bathrick said, see all of these things and avoid them, right? And we want a system that's going to be on board the drone, and it's going to do it by itself. So there are a bunch of technologies out there that, and I want to talk a little bit about them. A lot of them, given some of the applications we've talked about already, are just not practical, right? We could have ground-based radar. Ground-based radar are expensive and big. If we want to do extremely long distances, it doesn't really make sense. It doesn't give us the ROI we want. We could have a chase plane to follow our drone, which kind of defeats the purpose a little bit, right? We could have a chase vehicle. We could follow the drone. There are actually people that do this, right? They follow the drone in their car. Somebody's piloting the drone while somebody else drives. And they can have some success with this. But, cars just can't get some of the places you got to go. I talked about up north of San Francisco here, up in the hills, where we have, a lot of power lines that are surrounded by trees, are difficult areas to get to. So, it's not really so doable. You could do BVLOS with visual observers. Think back to that example of, having to, go around the world 6 or 7 times with the distance of power lines we have in the US, how many visual observers that would take, and how just, non-practical that really is. There are other technologies out there. In fact, we look at different technologies all the time. So like radar, LiDAR, acoustic sensors, etc. Most of the problems we have around these are, range, and then cost, size, weight, and power, right? If we want to put them on a drone, drones just can't handle the weight of them, and they're prohibitively expensive. And then they don't really give you the range so that you can detect something early enough to be able to react to it and make sure you maintain well clear. So, at Iris Automation, we've been developing what we think is the holy grail of onboard detect and avoid, and it's an electro-optical system. We basically have cameras that we put around the UAS, and we have computing power on board and software, and we will continually monitor the environment around your drone, and we use computer vision along with artificial intelligence and machine learning to be able to understand the environment round about, understand that, that's a helicopter, that's an airplane, and that's a cloud, and we don't need to bother about the cloud. And, understand how these intruder aircraft might be moving, and whether or not we need to instruct the drone to take an avoidance maneuver and get out of the way for a while, and then when the intruder is clear, resume the mission. And the system that we've built is, it's not expensive, it's lightweight, it doesn't use much power. You can put it on any platform, multi-rotor, VTOL, fixed wing, and it works with any autopilot. So, we've talked about how, why we might want to fly BVLOS, and through, that we want to keep our crews safe. We want that those cost savings, those efficiencies, and now with these technologies, it is doable, right? But what we have to also get through is getting waivers from civil aviation authorities. Generally speaking, we're not allowed to fly beyond visual line of sight. Now there are actually ways to do this. Civil aviation authorities, around the world, South Africa, and Transport Canada, here, in the US through the FAA's integration and pilot programs. The UK has a regulatory sandbox. And so, it is possible to get waivers, but it is a complex process. We're talking 600 to 700 page documents, mostly surrounding those 4 pillars of BVLOS that I talked about before. Now, there haven't been a ton of them given out. To date, there's been about 1,200 BVLOS applications, and I think 61 have been approved, which is not a great deal, but you can see that little bar chart there. It's definitely getting better, right? and Iris Automation, well, there's been 60 approved, or 61, I think. Iris Automation has actually got the only 2 that have been approved in the US without visual observers, and we've done that with our detect and avoid system. Actually, there was a police department that did manage to get one. I think it was called Chula Vista, I think. Actually got one recently. But their beyond visual line of sight waiver was actually very short distance. I think basically they went a couple of blocks and round a corner, and it was also very low altitude. And I'm not by any ways trying to say that, you know, what they did is not fantastic. It is fantastic. But I'm just highlighting that to show that it's on a different scale from flying, you know, 5, 10, 20, 50, 100 miles beyond visual line of sight. So definitely progress towards it, but the progress has been a little slow so far. You know, Iris, we're pretty proud of, and, you know, we're pretty proud of the waivers we've got to date. Last year, we get one at the Alyeska pipeline, you know, and it's basically, we actually did use ground-based radar with our detect and avoid, but no visual line of, and no visual observers. It was a 4-mile linear pipeline inspection. We got one in Kansas shortly after that with an energy company called Evergy. It was a power line inspection. That was 150 miles of BVLOS flight in 2 days, and, you know, no ground-based radar, no visual observers. It was just with our detect and avoid on board. And then we also got one at Transport Canada shortly after that. So, you know, we're making progress on waivers. You know, we've put a lot of work. Iris Automation is about 5 years old. We've been working pretty hard towards this for, you know, a long period of time. We have, you know, a bunch of PhD scientists working on this, you know, helping train our system. We have a flight ops team in Reno that we, you know, that fly drones, you know, towards airplanes on a regular basis. Obviously, we've mitigated the risk as much as possible, but they do this to test that our system actually works in the real world. We need to provide a lot of data on this to the civil aviation authorities around the world to actually prove that our system does work. But, you know, we want to get way beyond these handful of BVLOS waivers and get to the point that we're not asking for permissions. We want to be actually adhering to standards and flying BVLOS regularly and getting all the benefits from it. So how do we do that? And so at Iris Automation, we've been working with civil aviation authorities to really help them understand our technologies. Civil aviation authorities are typically used to radar, right, and not used to electro-optical systems. And, you know, we have, for example, simulators that can test our system in all kinds of conditions against all kinds of intruders. And, you know, we have to be able to prove that our simulators perform similar to our system would in the real world. We have to, you know, explain to them exactly how our system works, how we prevent against false positives, right? We don't want our system to see a bird and do an avoidance maneuver because it thinks it's a Cessna, right? We don't want it to look at a cloud and think that's a helicopter, you know. So because in that case, the system would be taking avoidance maneuvers left, right, and center instead of doing the job that it's supposed to do. So we work with CAAs around the world, help them understand this, and we actually help agencies develop standards. So, for example, we've been working on the ASTM detect and avoid performance standard for quite some time. We are working on complying with that ourselves. We think we're about 90% compliant. Probably in the next month or two, we should be fully compliant with that. And these standards span, you know, a lot of aspects of detect and avoid. You know, it's not just the device itself and proving it's robust and and proving that it reacts and behaves in the way it should, but then also pre-flight checks, post-flight checks, making sure the logs are all there, ensuring it communicates properly with the ground control systems. It's the standards are very detailed and a really tall hurdle to get over, but we are confident in that if we do comply with them, we will have a really great system. So we think it's worth it. We also realize that, flying BVLOS isn't going to be just achieved by having a great detect and avoid system. We really need to work, and when I say we, I mean Iris Automation and all the other companies out there. We really got to come together as an industry to develop systems that will allow us to fly beyond visual line of sight, and they comply with all of the regulations. I mean, an example from the ASTM detect and avoid performance standard is that, and it really gets into this level of detail, when our detect and avoid wants to perform an avoidance maneuver, it will do so autonomously, but it lets the ground control system know. And if the pilot in command has turned off audible alerts, we have to pop an alert on the screen. Now, we don't control the ground control system. We have to persuade the company that develops the ground control system to do that so that we can have a compliant detect and avoid. And there are countless examples like that that will be required for us as an industry to develop products that will be able to fly BVLOS and meet all of the regulations by the FAA and other civil aviation authorities around the world. And I think over time we'll be moving to type certification. We want to find partners and work with partners that have the same mindset around that. But I think also when we think of our customers trying to piece together a solution that will allow them to fly BVLOS is a difficult proposition, right? They have to be able to find a drone that is suitable, a drone that can carry all of their payload, a drone that can also carry their detect and avoid, that's suitable for their mission, and then also pair that with a C2 system and a ground control system, and package it all up in such a way that will comply with what the FAA's needs, right? And so if we can do this successfully as an industry, if we can come together to build drone bundles, I think it will not only make it better for us to collectively to comply with government standards, it will also help our customers, be able to recognize some of the benefits that I've talked about earlier. But even that's not really enough, right? We still have to get those waivers. We still have to get to scalability. And so what we have done to try and help our customers is we have built what we call a Waiver Resource Center. It's a software as a service SaaS application, so they can log in to any web browser. And it basically guides them through that process of getting a waiver. It's a multi-step process, and they basically ask questions, ask to upload documents, and give us basically all the information necessary to put together their full safety case, the full concept of operations, documentation that can then be submitted to their CAA for consideration. It's still a multi-month project, and it's not fully automated. We have our policy experts there to back the system up and to answer all the questions, to guide people through the kind of end-to-end process. So this is a really great avenue for people that really don't know where to start. You don't have any legal department internally, and really help guide you through the process. So that pretty much wraps things up. I mean, I think we've talked through really why you might want to fly BVLOS, what the benefits of that are, and then the potential of it, right? That return on investment is huge, and it goes across, all industries. If we think of the technologies that are there to help us, the safety systems like parachutes, the the ground control systems that we need, the C2 links, etc. And that we built Cassia, which we feel is one of the components, but certainly a key component to be able to fly BVLOS is having that onboard detect and avoid. And then, as an industry, if we can come together, work through the regulations, help build bundles together, get type certification, it'll be a way to really accelerate BVLOS for our customers and really scale this industry of ours that we all love. With that, I'd like to thank Interdrone for the opportunity to talk to everybody today, and I'd love to open it up to questions.
Yeah, so it looks like we've gotten a number of audience questions. We'll see how many we can get through here. To start off with, we can go with this one. Someone asked, why do BVLOS waivers most often get rejected?
Yeah, I mean, we see them get rejected for a lot of reasons. I guess the most common ones would probably be just incomplete, right? They don't speak to all of the risks that are there. They maybe don't describe how they're mitigating some of the risks. They maybe don't have full details of how they're maintaining their aircraft. We've seen a bunch of people look at other waivers that are out there and basically copy paste information from them, and that's that they pretty swiftly get rejected. Yeah, and then from a BVLOS perspective, it's not mitigating those risks. Wanting to fly over people, but not having parachutes, not having reliable enough technology. It's not understanding the performance of their C2 link sufficiently and being able to detail that. Maybe not having enough details around the traffic that they're going to be flying around. So not mitigating that air risk sufficiently. And then, maybe the team is not trained well enough. These types of things, I would say, would be some of the more common reasons they would be rejected.
Gotcha. Someone else asked if BVLOS can really start without unmanned air traffic management being fully established, and your thoughts on how UTM being established, thoughts on the pace of UTM being established to kind of help support BVLOS use cases.
Yeah, I mean, we are seeing UTM solutions being developed, much more readily these days. I think we're seeing, let me see. Actually, could you repeat the first part of that question? I missed that, and
yeah,
I wanted to make
absolutely.
sure.
So the first part was really just the simple question of not simple at all, but can BVLOS begin without UTM being fully established? And then beyond that, kind of what your thoughts are about the pace of UTM being established to help then support BVLOS use cases.
Yeah, okay. I think BVLOS can begin without UTM being fully established. I think I think we're seeing that now, right? We are seeing waivers getting approved. We are flying BVLOS. We're actively, pursuing additional waivers just now, as are our customers. I think we're probably, before we see things at a much greater scale, probably about 4 years out, something like that. And I think it's all going to be a ramp, right? It's going to become, and I think there's pressures just now that are helping accelerate it without, UTM being fully in place. We're seeing, companies and, governments putting more pressure on CAAs to accelerate it. I think certainly with COVID, we've seen a lot of progress. And then I think certainly in more rural areas, we are going to see approval there, without UTMs in the shorter term, where the I think the ground risk and the air risk is much, much lower. Yeah.
Yeah, no, I think that makes a lot of sense. This is an interesting one. Someone asked, given the complexities outlined today, do you think there will be a separate BVLOS license required? It's tough to speculate on.
Yeah, it's tough to speculate on. I don't know. I would love to get our policy experts to answer that one. I could definitely see that. I definitely see, you know, things are evolving now very, very quickly. For BVLOS, we're seeing, you know, certainly a lot of changes around regulations for, you know, the size of drones that will be used and the weight and so forth. I think it would probably make sense. Yeah, I think I could see that. Yeah.
Yeah. It's kind of a remains to be seen. Someone else asked, to get to BVLOS, do I need to use a service provider, or can I just achieve this with my in-house program?
Yeah, I think it depends on, you know, how mature your in-house program is. You know, if you're just getting started, there's definitely a lot of stuff that you're going to have to learn. You know, we see people that want to get started, but they don't have a drone yet. And making a decision on a drone, you know, we have customers that come and buy a detect and avoid from us, and they haven't got a drone yet. And we check in with them, and they, you know, months later, and they still haven't flown because they still haven't made a decision on a drone, right? So getting through, you know, there's a lot of decisions that have to be made. You know, you have to get your crew trained up. You have to make sure you're following maintenance plans and so on. You might need legal to get through the waiver process, etc. So I think the answer is it depends. You know, it depends on what knowledge you have internally. It depends on what your skill sets in-house are, and it probably depends on your use case too. Some are a bit more simplistic than others. For example, if you wanted to deliver a defibrillator in the middle of a city, that's a, you know, different prospect from doing infrastructure inspection in the middle of nowhere in Kansas or something like that, right? I think if you use a provider, they will definitely accelerate your program and bring a lot of expertise to you. But your drone program could also be, you know, your differentiator from your competitors. So whether or not you want to outsource that, that would be a consideration too. I'd say using an external supplier or provider is probably more expensive than you can do it yourself, and certainly long term. So there are a gazillion considerations here. I would suggest a good way to start there is to maybe you could actually contact us at Iris and maybe have a consultation with some of our team. They might talk you through that. You know, one thing that might be helpful is just we have a lot of partners, some of which, you know, can provide the service that we're talking about. So we can certainly speak to that and recommend people that could help you. But also we work with partners to bundle these systems together, right? So we have partners that we, you know, can work with to deliver the drone with our CATIA detect and avoid already built in. And so, you know, and we also provide ADSB in there and recommendations for C2 links and ground control systems. So you can get your program started a lot quicker by going down that kind of path. So I would suggest it might be a good way for you to go is just contact us at irisonboard.com and we can kind of point you in the right direction.
Good, yeah, I think that's a thorough answer, and it does make sense. It has sense that there are a lot of components at play there when you're making your decision. Someone asked, what are some of the physical limitations of a drone in the context of BVLOS that you've found? So for instance, like lost communication in terms of distance?
Yeah, so, it depends on a lot of things, right? Depends on your C2 link and your ground control system. Obviously, our detect and avoid has limitations too as to how far it can see. And, there's limitations on how far your aircraft can fly, right? So you need to think about a lot of things. You need to think about, what type of job is it that you want to do? Are you wanting to travel 50 miles? Do you only fly 50 miles? Do you need a stable platform? So you might want a fixed wing. Are you performing an operation where you have to hover and inspect and spend a bunch of time around a specific object to inspect it, in which case you want a multi-rotor. You might be somewhere in between where a VTOL aircraft makes more sense. You need to think about how you fuel your aircraft. Do you want a fully electric, or do you want fuel on board? Do you want a hybrid? You need, or detect and avoid some of the, restrictions about that, or how far it can see. And, you need to make sure that, you can meet risk ratios. So things like flying when it's foggy, you're going to be limited as to how far the system can see, right? And these are some of the things you got to think about. You got to think about the range of your C2 links. That's a handful of the things from a distance perspective. But certainly, I think you saw some of the stats from the waivers we've got. We did 150 miles BVLOS in 2 days. So the technology is all there. It's just about how you think about your mission as a whole and think about the potential risks and, think through how you're going to mitigate all of those.
Sure. I think we have time for about 2 more questions, and any questions that were unanswered, I'll be making sure that we're sending over to the Iris Automation folks to follow up on. But you had mentioned detect and avoid, and someone asked if you could give some background on how ASTM standards for detect and avoid will affect BVLOS.
Okay, so ASTM, if people don't know it, it's the American Standards for Testing Methodologies, I think the acronym is. And this is a pretty old organization, been around over 100 years. And what they do is define the standards for technologies that are coming out. And they don't enforce the standards. They basically define the standards, and when the standards get adopted by agencies, organizations around the world, like the FAA, then they become mandatory. And so the ASTM detect and avoid standard, that actually it hasn't actually been released yet. I think the comment periods are over, and it will be released next year, and I imagine it will be adopted soon after that. It details a lot of things like, how fast your detect and avoid must react, what's the probability that it will detect an intruder, what's the rate of false positives, what are his pre-flight checks, what are his warning lights, what else? It goes into, full documentation. You have to detail all of the performance metrics for your system, and show that you meet clear risk ratios that are detailed in the standard. And so complying with this is a lot of work, right? And, I think there's even aircraft out there that won't be able to comply with the standard because they won't be able to detect something and move out the way on time because they can't descend fast enough, can't turn fast enough, and so I think we'll see higher performance aircraft complying with this, but I think it's going to give us a framework along with things like the ASTM software dependability standard that will allow us as an industry to develop products that will give civil aviation authorities and the general public confidence that our systems are going to perform out there. We want to make sure that, you know, when our drone is, you know, when our drones are flying up there autonomously, that they perform better than a pilot. And, you know, I think the standards put on us through things like the ASTM, detect and avoid, we actually have to detect 360 degrees around our drones. Pilots cannot do that, right? Pilots get tired, or detect and avoid systems don't get tired. Our systems can react very quickly. Pilots not always well. And so I think through having standards like the ASTM DEA performance standard, it's going to make our products better. It's going to give greater confidence in them. And I think ultimately, you know, if we look a long distance ahead, like autonomous cars, we'll probably have cars driving themselves, and we'll probably have airplanes driving themselves as well, because it's going to prove that they're safer and they make less mistakes than pilots. Sure.
Well said. I think we've got one more question. How are you ensuring that weather does not impact BVLOS operations? And do you have any sort of way of getting low-level or boundary layer weather forecasts?
Yeah, so yeah, I could probably talk about this all day, because it's something that we talk a lot about at Iris Automation, because, you know, obviously we have an optical system. We use computer vision. And so, you know, when there's a lot of fog, for example, we can't necessarily see as far. And so the risk of, you know, not maintaining well clear is higher. And so, you know, like a normal pilot, right, we have to understand, you know, the conditions that we're allowed to fly in. And we do a lot of testing around that. And we actually spend a lot of time simulating different environments with our system. So how will it perform? And these are conditions that would be very difficult to analyze normal systems in, right? So with our simulators, we can see how our system would perform if there was light rain, if there was, you know, a little bit of fog, if it was, you know, a lot of cumulus clouds versus I don't know, stratus clouds. You know, if it was hazy, if it was a little smoky. And so we're able to give confidence around how our system will react in these different circumstances. And this will allow pilots and commanders to understand when they can safely fly their drone and have it still perform in the way that they would like.
Perfect. Yeah, it sounds like that will be crucial. So I think we're kind of coming up on our time. So as a reminder, the presentation will be available on demand within about an hour. And you can just use the URL that you used to log in today. And thanks so much for joining. And thank you to Jason for presenting.
Thanks, everybody, for your time. Thanks for listening, and thanks for the great questions. And thank you, Anita and Leslie from Drone, for setting this up. I really appreciate it. Have a great day.